Hello, this is Johnson from Aeronautical Engineering. The topic is about cavitation on hydraulic pumps. So, coming to the agenda, we are going through introduction followed by causes of cavitation, then effects of cavitation. Then we are going to discuss about the prevention of cavitation as well as the detection of cavitation. So finally, we are going to conclude the session with the conclusion. Moving to the introduction, cavitation is a phenomenon that occurs in hydraulic pumps when the pressure drops below the vapor pressure of the fluid, causing bubbles or cavities to form and collapse. This can lead to damage to the pump and reduced efficiency. So cavitation uh, is an phenomenon so that occurs when the pressure drops below the vapor pressure of the fluid. So if we consider water as our fluid, so the the vapor pressure of the fluid is 1 atmosphere. So if the water the pressure of the pressure of the water fluid decreases below the vapor pressure, then so within the 100 degree centigrades, that based on the how decrease how the pressure is decreased. So within the 100 degree centigrade temperature, the water will be evaporated. So the evaporation uh, makes the makes creates water bubbles. So the air converts into the water molecules convert into air molecules, and those air molecules makes a bubble inside the at the point of low pressure, and those air bubbles will be floated in the flow of fluid. So as they go out of the cavitation point, so out of the low pressure point, suddenly the pressure inside the pump, inside the pipe, in the fluid increases. So due to the increased pressure, the vapor bubble which is flowing inside the pump within the fluid will be blasted with a greater effect. So the process of blasting of those bubbles are quite different. So the the energy produced when the bubble is blasted, that can decode that can decode the strongest metals, the hardest metals. So just a small air bubble can wear wear the hardest metals. So that is how they are efficient. And we are going to discuss about them in the coming slides. Understanding the causes and effects of cavitation is crucial for maintaining the performance and longevity of hydraulic systems. So what we are seeing in the picture is the formation of air bubbles. So low pressured air bubbles. So the point at where the bubbles are forming is considered is actually the low pressure area, the area where the the pressure of the fluid is below its vapor pressure. So that is the reason those white bubbles which we are able to see in the picture are forming. So those white bubbles will be blasted uh, by making a uh, air jet at the surface, internal surface of the pipe, or at the propeller if that is a ship or a submarine. So coming to the causes of cavitation. Cavitation can be caused by number of factors such as high fluid velocity, low fluid viscosity, and high pump inlet pressure. These conditions can create areas of low pressure within the pump where the fluid begins to boil and form bubbles. Other factors that contribute to cavitation include poor dump design, worn or damaged pump components, and the use of improper fluids or additives. So these are the causes of cavitation. Let's move on to the effects of cavitation. What will be the effects of cavitation? Cavitation can have several negative effects on hydraulic systems, including reduced pump efficiency, increased noise, as well as the vibrations, and damage to pump components. These collapsing bubbles can erode the surface of the impeller and other parts, leading to decreased performance and eventual failure. In addition, the presence of air bubbles in the fluid can cause other problems such as foaming, reduced lubrication, and increased risk of oxidation and corrosion. So these are the several effects of cavitation process. So now let's discuss about the prevention of cavitation. How the cavitation can be prevented. So there are several steps that can be taken to prevent or minimize cavitation in hydraulic pumps. One approach is to reduce the fluid velocity by increasing the size of the pump or decreasing the flow rate. Another option is to use fluids with higher viscosity or lower vapor pressure. So these points can decrease the cavitation. These points may prevent the cavitation to some extent, but not at an 100% result. Coming to the detection of cavitation is much more important than preventing of cavitation, because so the detection of cavitation involves the causes of cavitation as well as the location of cavitation. So why the cavitation was actually occurring, what are the factors involved in the process of cavitation, these all will be included in the detection of cavitations. So if we detect the exact location of cavitation and the reason of cavitation, we may go through the preventive steps anyhow, but the process of identification or detection of cavitation is much more important. So let's look into the detection of cavitation. The detection of cavitation in hydraulic pumps can be challenging as the symptoms can be similar to other issues such as air entrainment or mechanical failure. However, there are some signs to look out for, such as increased noise and a vibration, reduced flow rate or pressure, and the visual inspection of uh, pump components for signs of erosion or damage. So these are the detection of cavitation processes. Let's move into the conclusion. So the cavitation is a complex and potentially damaging phenomena that can occur in hydraulic pumps. By understanding the causes and effects of cavitation and taking steps to prevent and detect it, hydraulic system operators can ensure optimal performance and longevity of their equipment. So the small phenomenon which cannot be see with our naked eyes, so it is making an huge loss, very uh, huge loss to the larger machinery majorly involved in the ocean transportations. So this is what about the cavitation process. I'll I'm going to end the presentation with this, and thank you.